Hi there, and welcome to this video on writing equations of lines given 2 points. This is a critical skill, and it is the skill that the last several lessons have been building up to. Please give this video a like if you find it helpful, and subscribe to the channel for more math content. Drop a comment below, let me know what you think, or if you have any questions. So we're not coming at this with no background knowledge. If you've been following along with these videos in order, you know we've already established the mechanics of writing the equation of a line. If we get partway through this lesson and you realize that you actually don't have that background information, please go back and check out those lessons. Math is sequential, and so you need to have the foundation before you move on to the next thing. So we already know that there are two pieces of information required to write the equation of a line. First, we need to know how steep it is, that is the slope, and we need to know where it is located on the coordinate plane. Once you have those two pieces of information, then you have enough to write the equation. So if I know where it is, so I put a point somewhere, and I know how steep it is, now I've narrowed it down to one line. There's only one line that meets both of those. Now, if you are given 2 points, this is the basic strategy that we would use to approach this without getting too specific. You're going to use those 2 points to calculate or count the slope. So you've got your 2 points, you've got your first point, and you have your second point, and you use those to obtain the slope, which means that you would now know the slope. And then you would use the slope and either point to find the y-intercept. So you find the slope, and then you actually have 2 points that tell you where it is located on the coordinate plane, and you can use either of those points to find the b value, and then substitute m and b into y equals mx plus b to write the equation. Okay, now that is your basic strategy. That is how me or any of your math teachers would find the equation of a line. Now, there's a couple of things that you can do once you have the slope. So there's other forms of the equation. So we might go about it using a different strategy other than finding the y-intercept, but essentially we would use the 2 points to find the slope, and then we would pick one of those 2 points to get the equation of the line from there. So let's take a look at an example. Write the equation of the line containing the points -1, 6, and 2, -3. And there is only one line that will go through both of those points. That's a critical geometry fact there, that 2 points determine a line. So we know that the formula for slope is the rise over the run, or y2 minus y1 over x2 minus x1. And the subscripts there, as a little refresher, are just delineating point 1 and point 2. So y2 just means the y coordinate for point 2, y1 is the y coordinate for point 1, because we don't want to have this y minus y, that would be 0, or x minus x. And you can name these points either way. So a lot of times I'll just take whatever the first point is, and I'll say that's point 1, which would make this x1 and this y1. And if this is the second point I see, I'll say this is point 2. So this is x2, y2, but you don't have to do it that way. You could, there's nothing magical about the order of the points. The only rule that you have to follow there is once you pick point 1 and point 2, you have to stay with that choice throughout the entire problem. So now let's go down here and plug that into our slope formula. So y2 is -3 minus y1 is 6. And x2 is 2 minus x1 is -1. And a quick reminder there, you have a minus sign from the formula. Okay, that first minus sign is coming from the formula. The second minus sign is coming in attached to the x1. Now, you might want to change some of these to a plus negative. I'll leave that up to you. -3 minus 6 is the same as -3 plus -6, so that's -9. And then this would be adding the opposite here. So minus a negative is the same as just adding. That's a messy way of saying 2 plus 1. So that's 3, and -9 divided by +3 is -3. So now I have found my slope. Now I can pick either of those points to find the y-intercept. And so I'm going to go, I don't know, we'll pick 0.1. So we'll use the y coordinate from 0.1, which is 6. We have -3 times -1. That we're using the x coordinate from 0.1. So we're just borrowing the y and the x from 0.1. And then we'll have plus b. We're looking for b, a negative times a negative. And then I said b and I wrote a b, and 6's can already look a little bit like b's. So negative times a negative is a positive. And then we will subtract or add -3 to both sides. 6 minus 3 is 3. And 3 minus 3 right here is 0, leaving me with just the b. So my y-intercept is 3. And now I can go and plug in my m and my b. So m was -3, x plus 3. And we get the equation for that line. Sorry, just bear with me a second. I'm having an issue with my thumb, and my thumb hurts, so it's kind of hurting to do the writing here. All right, so there's the equation of my line. Now, what if we had picked the other point? Okay, so we already found the slope to be -3. I'm not going to drag you through that, but I picked the point -1, 6. What if I had picked the other one? Because in those directions, I said you can pick either point. Well, how do you know you're going to get the same equation? So let's try the same process, but we'll try it with the other point. And so we will use -3 for the y. We've got -3 for my m value, and then we'll have 2 for the x value. -3 times +2 is -6. And then we will add 6 to both sides. -3 plus 6 is 3. -6 plus 6 is 0, leaving me with just the b. And lo and behold, I have the same y-intercept. And so we would plug that in. -3x plus 3. And if you need to rewind the video and look back on the previous slide, you'll see that's the same equation. Okay, so you can pick either point that you want there. And I am thinking I don't want this written over here. So a second. I'm just going to move that over a little bit. So we've got y equals mx plus b. So y is equal to -3x plus 3. And it is the same equation, because that was going to pop up over on the side there. Either point works, but if you have an option, okay, so if you actually have the choice of 2 points, choose smaller numbers over larger numbers. So if you've got a 1 and a 2 and a 10 and a 20, pick the 1 and the 2. Positive numbers over negative numbers. So if you have one of your points is like 2 positive numbers and the other one deals with negatives, avoid the negatives if you have the option to do so. We didn't have the option in this problem, like both of the points had a negative. And then numbers that avoid fractions. So you choose numbers that are going to avoid fractions. That might take a little bit more experience as a math student to be able to look at a point and see like what's that going to do when I multiply it by the slope. But those are some options. There's no wrong choice, so nobody can mark you down if you pick like the bigger numbers or the negative numbers. It's just that's like a smart way to do that, because those are the things that tend to cause problems. All right, just another example to work through this. So this time I'll just change it up. We'll call this point 2 and this point 1, just so we're not getting too in the habit of thinking, okay, I have to pick the points a particular way. In fact, you want to pick them in whatever way is going to make your arithmetic nicer, is how you want to pick them. All right, our formula for slope is the difference in the y's over the difference in the x's, and we're just going to do that straight substitution. So 3 minus 1 over 2 minus -2. 3 minus 1 is 2. And then remember, minusing a negative is adding a positive. So that would be 2 plus 2 is 4. And 2/4 does simplify to 1/2. So I have my slope is 1/2. Now, in this case, I think there really is a better choice for which point I should pick. I think I should pick the 2, 3, because that avoids the negative numbers. Now, somebody might say, oh, but the other point has smaller numbers because 1 is smaller than 3. That's true. And if you feel really strongly like you'd rather work with a 1 than work with a 3, you can do that. It's not wrong. For me personally, I would rather avoid the negative. And So we're just going to go ahead and plug that in. So y equals mx plus b. My y value, I'm going to use the 3 equals 1/2 times 2 plus b. 1/2 of 2 is 1. And then we subtract the 1 from both sides. 3 minus 1 is 2. 1 minus 1 is 0. And that leaves me with b is 2. So going back and plugging that in, we get y equals 1/2 x plus 2. Okay, it should not be an overwhelming amount of work that you've got there. Okay, it should not be like tons and tons of work. I'm doing more work than is probably necessary to do. If I were doing this on my own, I probably would not write down the formula, but I've been doing these problems for, oh boy, close to 35 years at this point. So at the time of this recording, but yeah, so I've got that formula pretty locked in. If you are new to this, you don't have it locked in. So I would write it down. I would also go straight to that rather than writing the minus and negative. And I would probably, now this I would just not bother writing down the formula over and over again. But I do that when I'm demonstrating it to make sure that we're sure of where all the things are coming from. And I think it's good form for you guys to do it. All right, so what do you do if you get stuck? Many students get stuck trying to use memorized procedures and often forget that they have other tools to figure things out. And I see this a lot of the time in my own students where they want every problem to look exactly the same way. And when they get stuck, they don't really think, well, is there another way that I could figure this out? And this is why your mental models and your fluency moving between an equation and a graph come into play. Because if the only way you know how to write the equation of a line is by copying the steps that someone else told you, then you don't really have the resources for when you get stuck. And you will get stuck, like you will forget something and get stressed out or whatnot. So what else could you do? So let's say you have this, write the equation of the line passing through 1, 4, and 4, -2. And you are just blanking out. You're like, I don't know what I'm supposed to find, or I know I have to find the slope and I don't remember the formula. I'm getting it backwards. I don't know what to do. Well, let's step out of that process altogether and say, well, what other things do you know how to do? Well, we know how to plot points on the coordinate plane. So I'm going to take both of those points and plot them. So I'm going to go over here and plot the point 1, 4. And then I'm going to plot the point 4, -2. Okay. And so now I can actually sketch in the line there. Like I know what I'm looking for. I'm looking for the equation of that line. Now, what you've done just by plotting those points is you've taken this from kind of the abstract, there are points on the plane, to something more concrete where you can actually see the points on the plane. And just by doing that, I can tell you a couple of things. I can tell you that the slope is negative. Okay, I can tell you that the slope is negative because the line is tilting downward. I can also tell you that the y-intercept, now it looks like it's 7, but look at where I kind of drew that. I drew that line high. 7 is probably high, but the y-intercept is probably, like if you look at where I'm circling there, in the vicinity between like 4 and 7 somewhere, depending on how good of a job I did with my line there. Now we can actually make that more precise, and I'll show you how. So let's see if we can find the slope another way. So you blank out on the slope formula, but you do remember that slope is rise over run, and I've rarely had students forget that. Okay, that they do remember. So let's just find the slope by counting it instead. So I would start here. I count down 1, 2, 3, 4, 5, 6. So my rise is -6. To get between those 2 points, I count down 6, and my run is 1, 2, 3. My run is +3. So -6 divided by +3 is -2. So let's say like you don't remember the formula. Okay, fair enough. Like now we've got the slope. Okay, and we're fortunate we have points that we can do that with, but a lot of times in your math class you will. Now that we know that the slope is -2, we can actually count backwards and see if we can find the y-intercept. So if I like count this way and I go like left 1 up, or well, I should probably do this. Like I go up and left. So what I'm doing, like a lot of times when we do the slope, we'll picture it as this, like down to right 1, but you could also do this where it's up to left 1, and that involves a little bit of fluency with your negatives, that you know that both of those things would be a -2. So if you watch what I'm going to do over here, I did not want to do that really, but I didn't want to erase it all, but there you go, is you can count up to left 1, get yourself another point. Up to left 1, get yourself another point. Up to left 1, we already knew that point was there. Up to left 1, and what I have found is the y-intercept, and I am reasonably confident of that because now that I know the slope, now I don't have to eyeball it. I can actually count up to left 1, up to left 1. And so the equation for this line is y equals -2x plus 6. And I am very confident that I have done that. And basically, I've reverted over to using the graph to do it instead of using the algebra. Okay, and there's absolutely nothing wrong with this. This is not cheating. This is not like you're just using a different tool to figure it out. So if a question is a multiple choice question, then that's enough to answer it, okay? So if you've got a multiple choice question, the multiple choice question might tell you to do a certain way, but at the end of the day, you're just gonna bubble off A, B, C, D, E, whatever you're gonna bubble off. So that was all you need to do. Now, if a question requires you to show your work, you can use the known answer to help you bridge the gap. So sometimes on your tests in class, the teacher is going to require you to show your work a certain way. So now you've got the equation of the line, y equals -2x plus 6. Now you've got to figure out, can I come up with what the teacher wants to see to give that? So we know the rise is -6. So for example, and the run is 3. And you know that the slope is gonna come out like that, you got to figure out what to put in there for the slope. Okay, so you're kind of blanking out. You're like, crap, I don't know what to do. So you know that like the top number has to come out to a -6 and the bottom number needs to come out to a +3. And you've got this like mix of numbers to work with. So you might look at, and the 4 makes it kind of convenient. So you could kind of get lucky with this one, but you might do something like this. 4 minus 1 gives me 3. And then what if I did, so you'd like do this one minus this one like that way. And then, -2 minus 4 would give me -6. Now, you're really coming at that through the back door, but your teacher doesn't know that. And I'm saying that as a teacher. Like if a student showed me this on their paper, I would have no way of knowing that they didn't come up with it this way. Okay, and then from there, you've got your -2, and then you can hopefully figure out something to do to come up with a 6, but maybe you jump there and you're playing for what I call like playing for partial credit. Okay, so you can do that and kind of make the work fit. And then if you remember y equals mx plus b, and now you've got the -2, okay, and so you can plug that in, and if my students did this and the 6 came out of nowhere, it would get a question for me on the test. I would say, where did you get a 6 from? But maybe you can figure out, like, once you get it that far, you're like, oh, now I remember what to do, and you can fill in the rest of it. And that's what savvy test takers do. It's pulling in from somewhere else so you don't get locked into one way. Like, should you be able to do it both ways? Yes, you should. But we're also human, and sometimes we panic. And rather than leaving it blank and not showing your teacher what you can do, go over to some other strategy and say, okay, well, I don't know how to do it this way, but I can do it this way. All right, so that's all we've got for this lesson. In the next lesson, we're going to look at how we use this information to create mathematical models of data, which is where it gets applicable more than just like random points. Don't forget to give this video a like if you found it helpful, and subscribe for more math help. Drop a comment, let me know what you think, or if you have any questions. I'll see you in the next one.